I'm going to show you visually what happens as we do the calculus. I'll show you that along the way, and I'll walk you step by step through the calculus proof. This video is part of a playlist on monopoly theory, and I'd encourage you to watch the other videos as well. The marginal cost curves look something like this, with a downward sloping demand curve. Remember, the monopoly's demand curve is the market, the marginal revenue curve. Also, I'll draw in the marginal cost curve and the average total cost curve. The monopolist produces where marginal cost is equal to marginal revenue at a quantity, I call it QM, the quantity produced for the monopoly. And they produce at a price of, if I go straight up right there and over, PM, or price the monopoly would charge. The total revenue curve looks something like this. It's a curving up and then down, and total cost curve looks like this. And the monopolist will produce where the slope of the total revenue curve is equal to the slope of the total cost curve. In fact, I'm gonna draw this a little bigger for you too, and that's the profit curve. Let me draw this larger so you can see it. I'm gonna put the quantity in, and on the y-axis I'll put total revenue now, and that's the total revenue curve. Also on the same, I'll plot the total cost curve. Looks like that. Total cost. And finally, I will put in the profit curve. And profit looks like this. There. And label that profit. The slope of the total revenue curve is equal to the slope of the total cost curve where profit is maximized. The slopes are equal. And we know that is marginal revenue and marginal cost. And at this point, profit is maximized right there. Now I'll focus just on the profit curve as I step through, and I'm getting ready to do the calculus proof, so just hang in there with me. I'm going to set it up for you. So here's the profit curve, and the monopolist maximizes profit at that point where slope is equal to 0, right there. And the change in profit divided by the change in quantity. So what happens to profit as quantity changes or increases in this case? We have that delta is a change in, by the way. So we have D means delta. So D pi, so I'm using pi as the symbol for profit. That's common to do in economics. Divided by the change in quantity, or DQ. D pi dQ. And this means what happens to profit as quantity changes, and that's what I'm going to prove using calculus. So how do these things change? Obviously, profit's not constant as quantity changes. And the rate of change can be measured by the slope of the profit curve. And that's where it's maximized when slope is equal to 0. So when I take the first derivative, which I'm going to do, I'm going to take the first derivative, set it equal to 0, and solve it. That's where profit is maximized. So here we go. Ready? Let's go. It turns out that profit is equal to total revenue minus total cost. Profit is equal to price times quantity, which is revenue, minus total cost, which is a function of quantity. The total cost curve looks something like this. What happens to total cost as quantity increases? How does it vary? Also, it's not constant either. So I'm going to say total cost is a function of quantity. So profit is equal to price times quantity, and I'll just use P and Q now. So profit is equal to price times quantity, P times Q, minus total cost, which is a function of quantity. So profit is equal to price times quantity minus, and I'm going to show you that total cost is a function of two things. Total cost is total variable cost and total fixed cost. So total cost is equal to total variable cost plus total fixed cost. And you'll see in a moment why I'm doing this, so just hang in there. So now I have, put the labels back, I'll get rid of the total cost curve. The change in profit due to a change in quantity is equal to price times quantity divided by a change in quantity minus a change in total variable cost divided by a change in quantity minus a change in total fixed cost and a change in quantity. There's a reason I'm making that gray, by the way. So let me plot this out. I'm going to plot total fixed cost, and notice it's a horizontal line. The slope is 0, and it doesn't change with quantity. Again, slope is equal to 0, so I can just say that does not change, so I can ignore that and get rid of that part of the equation. Now I'm going to write this in proper calculus notation. And I'm using D's instead of the change in. And I'll use that calculus notation all the way through. So it's going to turn out that this part of the equation, that's going to be marginal cost. And so let me plot it out for you again. So if I have change in total variable cost, and look at the slope of the line, which is my first derivative, this is going to equal to that part of the equation, and that is marginal cost. In other words, how does total variable cost change when quantity changes? Now I'm going to look at the other part of the equation. And that part right there. And I'm going to have to use the product rule to take the derivative of that, and I'll tell you what that is in a moment, the product rule. Remember, P times Q is revenue, so I could graph this out as well, and I'll show you the graph what that looks like. So I have quantity again, and total revenue on the y-axis. The total revenue curve looks like that. And how does revenue change when quantity changes? Again, revenue is price times quantity. Clearly, total revenue changes as quantity changes. The slope of the total revenue curve is a tangent line, and it turns out the slope is the first derivative of that equation, and it's marginal revenue. Now the product rule is defined as, I guess I don't need this after all. Let me get rid of this stuff on the left again. There. So the product rule is if I want to take a derivative of two items like P times Q or two functions, the way I do that is I take the first function, in this case it's P, times the derivative of Q, plus the derivative of P times Q. So I have P, which is price, times the change in quantity divided by the change in quantity, and I'll talk about that in a second, plus the change in price due to a change in quantity, which is the first derivative of the P, times Q. So let me write this over again. And this is equal to P. I'll just pull the P down. The change in Q due to a change in Q is just 1, so I won't write that 1 out. So it's P plus, and this is typically written with a Q first, and then the change in price to do a change in quantity. And that is the first derivative of that part of the equation. Now let me pull that down, and then pull this other part down. And this is, how does profit change when quantity changes? So let me move that up and start over. So I'm almost done, so hang in there. This part of the equation is marginal revenue minus this part of the equation, which is marginal cost. And if you recall, profit is maximized when the slope is equal to 0. So I'm going to set this equation equal to 0. I'm going to do a little algebra. I add marginal cost to both sides of the equation. So I have marginal revenue is equal to marginal cost. What about that? And that's where profit is maximized. So there you have it, the calculus proof for monopoly theory. Hope you grasp it. Again, I drew some graphs, did the calculus. I would really encourage you to watch all the videos in the playlist on monopoly theory.